Welcome to IS 259, Database Applications. Let's get started as we begin to learn about databases. Please remember that this and all presentations are protected by copyright law. So just what is the purpose of a database? Simply put, it's to keep track of things. This leads many people to wonder why we would need a database when we could use a spreadsheet for this. Well, a database allows us to store more complicated information than a spreadsheet does. When we try to store more complicated information in a spreadsheet, we begin to encounter problems. One of the most prevalent of these problems is redundancy. The same information might get entered multiple times. This can become a problem if one instance of the information is deleted, updated, or inserted incorrectly. Let's look at an example. In this sheet, every row has information for students, advisors, and departments. If a student were to change his advisor, in this example, from Baker to Tang, not only will we need to change the advisor name for the student, but also the email address as well. And in some instances, if he were to change, say, to Valdez, we would also even have to change the department information. Also, if Mr. Valdez were to change his email address, he's listed in more than one place in this spreadsheet, which means we would have to change the email address in multiple places too. If we were to delete a student, when we delete that row, we not only delete the student information, but we also delete the advisor information and the department information. Likewise, if we insert new information, in this example we inserted new department information, then we're missing the information for students and for advisors. Relational databases can address many of the problems that we find with spreadsheets. In a relational database, information is stored in tables, with each table holding its own set of information. This breaks our spreadsheet rows into different tables, which helps avoid some of the problems of redundancy. At this point, you might be wondering how we can put this information that's now in separate tables back together again so that we can find out all we need to know about one part. We must create relationships between the tables using the value of the data. Let's look back at our example. First, please notice that we broke the spreadsheet now into three separate tables, one for department, one for advisor, and one for student. I also want you to notice the relationships that have been formed here, indicated by the red arrows. There's a relationship between the student table and the advisor table made through the advisor last name. That joins those tables together. Likewise, there's a relationship between the advisor table and the department table through the department name, which joins those. Our tables are now joined together by the value of the data. Now let's look at the problems we saw in the spreadsheet. If we wanted to insert a new department, we could simply do it in the department table. We would not need to insert any information in the advisor table or the student table. In the student table, if the student's advisor were to change, all we need to do is change the name in the one place. We don't need to change any other information since that information is stored in a different spot. Also, if an advisor's information changes, if Valdez was the one in our previous example, if his email changed, for example, all we would need to do is change it in this one place. Finally, if we need to delete a student, we simply delete that one student out of the student table. When we do this, it does not affect any data in the advisor table or the department table. Yes, it might sound like building a database could be more work, but hopefully you can already see that its advantages are well worth it. We can store much more complex data without the problems that are caused by spreadsheets. Thank you for your attention. This concludes our first lecture this week. Okay, now I would like to take a little bit deeper look into the relationships that we form between these tables. In this overview, I want to mention a constraint that a database management system will enforce called referential integrity. Database management systems enforce other constraints, but I want to take a particular look at this one since we just covered a relational database, a small database example where one table was related to another was related to another. Referential integrity constraints make sure that the value that relates those tables stays stable, that it doesn't just disappear from one of the tables and keep that record from being able to relate to another table. So I've made a very small example here with just two tables and much smaller tables than in the previous example. An advisor table where we have the advisor ID, advisor last name, advisor first name, advisor email, and a student table where we have the student ID, the student last name, the student first name, the student email, and then the student advisor ID, which is how we relate the two tables. This is where we join them. In our previous example, they were joined with advisor last name, but it's usually a best practice to have a numeric value for this. All right, so now I want to create the relationships between these tables. Go to my database tools and choose relationships, and then to select my table, and I want to add that relationship. Now I have both tables here. All right, now to make the relationship in Microsoft Access, it's pretty handy. You can just drag like that. All right, now we have edit relationships. We've got a relationship from advisor ID to student advisor ID, and this option here, enforce referential integrity, I'm going to check that so that we can create this relationship with this integrity, and I can show you what it does. All right, we now have our relationship. The 1 and the infinity symbol mean that for every student, one student advisor can have many students. Okay. All right, now let's go back and try to add. Oh yes, I do want to say, let's go back and try to add some students. Okay. We'll add student last name. We'll add famous Mr. John Doe. He will be John at email.com. We'll type in an email, but that's okay at this point. All right, now when I try to add a student advisor ID, look what happens. Say I already know that he has advisor number 2 from a sheet of paper I have on my desk. All right, but when I try to put number 2 in here and hit enter, I get an error message. That's because of referential integrity. I can't change a record without that related record in advisor table. So what I'm going to do is go to advisor table, and I'm going to make this advisor Smith, Bill E. Smith at email.com. Okay, and now I'm going to make this Jones Sue SJ at email.com. Now I have an advisor number 2. So when I go back to my student table and I try to add now this number 2, there it goes. I'm allowed to add number 2 because of meeting the referential integrity constraints. One last thing I want to show you very quickly is now, since I have the relationship, I can click on Sue Jones and see the students who are related to her. One more advantage here, relational databases. Thank you very much for your attention. This concludes this section of the video lecture. Okay, we're now at the third part of our video lecture, and I want to introduce you to one more aspect of databases that is very important, and that's structured query language, or SQL, as I'm sure you've all heard it mentioned. SQL is a language that we use to process these databases and their tables. We can retrieve information, we can insert information, we can create a table with it. We can do many things with SQL. And so what I've done here is I have taken our student advisor tables that I made up, and I have created a couple of SQL queries so that I can show you how the queries run, what the SQL itself looks like, and also if you're working in a simple personal database like Microsoft Access, how it can allow you to set these queries up a little easier. Okay, first I want to query just first of all, notice that I have added something. I've added some records here to our databases, both our student databases and our advisor databases. Okay, I've also added an extra field here with student state. So what I'm going to do now is I've got a query that I wrote where I want to find all the students who are from Mississippi. So here we go. Run that query, and there we go. We get John Doe and Al Watson. Okay, with student ID 1 and student ID 5. If we want to check back, since this is a small database, we can do that. And here we can see the state is Mississippi, and it is John Doe, ID 1. The other student from Mississippi is Al Watson with ID 5. So, in this tiny little example, we know that the query worked properly. Okay, now, let's look at the SQL itself. Okay, I'm going to go here to SQL view, and now we see our different statements. We have a select statement, and the select statement is telling us which items we want to show. Okay, we want to show our students.student ID. That means the student tables and the student ID field. We want to show the students.student last name and the students.student first name. Again, the student table and the field of first name and last name. Okay? Now comes the from statement. That is the table where we're looking for this. And then the where is telling us what criteria it is that we want to match to be able to select these things. We only want to select students who have a state equal to Mississippi. All right? And so that's how the SQL works there. Now I did another one where the students have advisor 2, all right? And what I did with this advisor 2 is I had it, there we go, select the students, their ID, their name, and the advisor name. I didn't have it select the advisor ID. That really doesn't mean a lot to us. You probably want the name, okay? So we got John Doe, Tony Collins, and Don Garcia, who all have Sue Jones as their advisor. Okay, the way that works. All right, now I want to show you with this one just how easy it is in Microsoft Access to set this up. Okay, if I go to Design View here, looks a little different than that SQL view. In Microsoft Access, we were able to we have our tables shown. We were able to select the field in the table right here. We were able to put check marks on the ones that we wanted to show, and here the student advisor ID, what we did here was we have a row here called criteria, and we made our criteria here criteria of 2, meaning we want the student advisor of 2. All right, and that's quite simple. This is a much more complicated set of SQL. I'll show you the SQL view. As you can see here, we had the select statement, but because of what we were doing, we had to join, we had to use this join statement here, all right, our 2 tables together, where our student advisor was 2. In this class, we'll learn about the SQL more, but I did want to show you the simplicity that Microsoft Access puts on it. Thank you very much for listening.